This is good.
Yep.
And then,
Yeah, go right across that F1.
where's the other one here?
Yep, oh, yep, good.
This is bad.
Right on that pad. Yep. So, whoop, that fooled everybody. Yep, it's open. So here's what.
Hey, it's Terry from D-Lab, and I got a special project today. It's a White's metal detector, the model 6000 DISL Pro. Never had one in the shop before. Should be a great project. Hey,
Hey, Grandpa, that's not a guitar amp. Are you going to convert that into a heavy metal amp?
well, no, I actually repair metal detectors. I just don't put on very many videos, but that'd be kind of cool, but no, I'm not doing that.
Huh, well that's too bad, because it would have been a deep tone.
Probably would have been. Hit the road, I got work to do.
Alright, bye.
Alright, so this is a very desirable metal detector, okay? These still sell for like $250 to $450, and this thing is probably, I don't know, 30 years old. So that says a lot, you know, for a metal detector, because the new ones are like, what, 700 bucks or so? That's what I just paid for my new little MX7 thing that I got, right? Alright, so here's the complaint. The guy has owned this since it was new. He used it one season. He shut it off. It's been sitting. He said he put it in the batteries, flipped it on, and it was completely dead. Okay? I had a video in the past where I showed another model that was also dead. Okay? So I know what to look for. Alright? So I'm going to show you real quick. I've already got the screws loose from the case. I never troubleshoot these using batteries. The reason is, if you're troubleshooting this stuff using batteries and something goes wrong, that battery is going to give you all the current it possibly can and damage these things even worse, right? So what I do is I use the power supply, okay, instead of batteries, because I can control the power supply. But the first thing we need to check is why is it dead, okay? So I always take my ohm meter. Remember I showed you how to use an ohm meter the other day?
Yes.
So if this was a switch, this is open and that's closed, right? You see the 0 ohms and then it opens. Remember? We did that the other day, all right? So if I were to go across the battery terminals, all right? So these are identified. This one has a positive and that one's got a negative. Alright, so what I'm going to do is I'm going to put my meter across those two prongs, okay? So if I turn on the switch, I should see some kind of resistance, wouldn't you think? That is just like I'm doing this, right? It's completely open. So something is open between these power terminals and the metal detector, okay? So what I'm going to do is flip this up so you can see a little bit better. Like I said, that's positive terminal, this is the negative. So to see if the negative's bad, you take my meter read, right? That's another Daytonism. Go to the case. Oh, you're yawning. I see this is good stuff for you. Alright, look, we're going to go to the case, to the negative. What do you see on the meter?
15, 16 and going up.
Right. You're seeing resistance when I'm doing that, right? So that's a sign that that terminal is probably going where it should go, right? Now here's a positive one. Now we know the positive terminal went to that switch that I just turned on and off, and it didn't do anything. So I'm going to go from here. Now if I take my lead and go to this little foil, look at the meter.
0.
Right. So now I'm going to go down to 200 ohms. I'm going back to that same foil. So that's good, right? Now, if this switch is supposed to be switching on and off the power, then that means this terminal has to go to the switch, right? It makes sense. So what I'm going to do, it's kind of hard to do, but I'm going to go across all these terminals. You watch that meter and you tell me if you see go to 0. I'm going to hit every terminal on the switch. Seen anything?
Yeah, 1. Oh, 1.
That's a 1. That's open. Let's do this. If I do this, hear that? Beeps. That tells you
that the meter leads are touching, right? Just like if I'm going here to this foil, right? So if I do that, and I go, some of these are hard for me to see, right? So there's some right here. I'm hitting those. Do you hear anything? No. Okay. Now I'm going to go back under here. Nothing. So somehow that positive terminal is not making it from here to there, like that far. It's not making it. And you wonder why. Okay, so I'm going to show you a little trick. I know this may be a little bit above you. This is called a schematic. Okay, I actually got this schematic from White's a long time ago because they knew I was fixing their stuff. Okay, all right, let's cut, and I'm going to show people this schematic, and then I'll explain it to you what's going on. Okay. All right, Emmy. So right there, you see that square? That is the battery. That would be this battery pack, right? That goes in the back of the metal detector. And then that is the switch. And of course, that is the phone that always rings every time I shoot a video. Yeah. Isn't that great? But you know what? I'm just going to keep going, right? So it goes from the battery and it goes to the switch. Remember I told you that we're open between the switch and the battery? Okay, let me get up here where people can see this. Battery, switch, right? We have open from here to here. Do you guys see what I see right there? Let's see if Emmy catches it. All right, buddy. So from the battery to the switch, what is in between? Do you see it?
A squiggly line.
Right, a squiggly line. And what does that say right there?
F1 trace.
Right. This is a fuse that is actually a trace on the circuit board. It's hidden right there. If you look right there, let me get a light. I want you to take a peek. Look right there. Do you see that?
Yep.
What does it say? Right there.
I can't see it. It's
I thought you said you...
upside down.
Oh, okay. Well, here, stick your head in there. What does that say right there?
AWGF1.
Ah, that is the fuse. So do you see that little tiny line right there, buddy? See that?
Yeah.
You know what that is? That's the broken fuse, all right? Let me get the camera in here so people can see it. All right, right there, people, where it says AWGF1, there's a very fine trace on the circuit board, okay? And that little trace is more than likely broke, and that is why the metal detector is dead, right? So I'm going to let Emmy, I'm going to let you measure across that trace, okay? All right.
This is good.
Yep.
And then...
Yep, go right across that F1.
Where's the F1 here?
Yep, oh, yep, good.
This is bad.
Right on that pad, yep. So, whoop, that fooled everybody. Yep, it's open. So here's what we're going to do, buddy. Pop that out of there. So I looked up the specifications on that fuse, and they're saying it should be right around a 1/2 amp is what you would replace it with if you were to put in a fuse. And that's what this is. This is a 1/2 amp fuse. So I'm going to solder that to those pads, and then we'll bring this thing up on my power supply. Check it. Okay. All right. All right, buddy. So this is a little bit of brain surgery. So I've got the new fuse sitting here. I put a little piece of rubber tubing on here so it can't short. So I'm going to take our new fusee.
Fuzzy.
Fusee.
Fuzzy.
We'll lay him in there.
Fuzzy.
And I'm going to tack solder it right behind the positive terminal. Okay? Try not to burn myself. So I'm going to heat this up. Moved, of course. It's alright. Yeah. Hold on.
Aye.
This is the problem when you're working in these little tiny areas, okay? I do this crap all the time. Hold on. Okay. So that side's on. Okay. You know, I always thought that I should be like a dentist.
Huh.
Or maybe a surgeon. Because I've always liked this little intricate type work. I'm going to hit this one real quick again. Just like that. So, the next step, we're going to power it up on my power supply. Remember I told you, I never check them with a battery. And why don't I check them with a battery?
Because everything will explode.
Yes.
Okay.
Only if something is shorted, the battery can cause more damage. Okay, but in this case now we've got the fuse in there. So with the fuse in there, it's going to protect it. Okay, so I'm just going to leave this the way it's sitting because we are already on the on position. Okay, and we're going to swing my power supply around here. All right, these battery packs are rated for 6 volts. That's what the metal detector wants to see. Okay, so we have a DC power supply. You've got a meteroid. I want you to hook up across the positive and negative and see what we got. Go inside the hole there, Feldman. Okay. Okay, it's not going anywhere. What are you looking at? How about your meter? Meter, 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 meter. Over there. Meter. We're looking for 6 volts. Okay? I've got 6 volts. Okay? So this is called current adjustments. So if I were to take these and short them, you would think it would spark, right? But it won't because the power supply is protecting it. Okay? Alright, so now we have a set. I'm going to pull off one of my leads. Negative goes over here. Okay? Positive here. Then we hook up and we're going to look and see if that meter goes up. It does. Problem is, I'm going into current limit. Let me see if I'm hearing a tone. Alright, so I took off the power supply because I was noticing that we were drawing like too much current. Should have been drawn under a half amp. To where now I get to pull the whole circuit board out and try to figure out what's shorted. Oh, hi.
Well, I see that this project just turned into something more than what you thought.
Huh.
Well, I think that you need some thinking juice.
Yeah.
There you go.
Isn't this typical though?
It is very typical.
You know, I'm like, oh, I just popped that trace, probably just this little diode shorted, fix it in 10 minutes, and now it's going to be hours.
I keep trying to tell you that, but maybe one of these days you'll listen. I love you, dear.
Love you too.
Yeah.
Out. Alright, so at this point, I need to remove all the circuit boards out of this thing so I can see the top side. See if there's any components that are showing signs of damage, but I'm pretty sure we've got something shorted. Hopefully, when it got the reverse bias, it didn't go in here and blast U20. Because if it took that out, this thing's scrap metal. Then maybe I could make a heavy metal amp out of it. Alright, so another common problem with this metal detector. Right down here, there's a pair of 470 microfarad caps. Okay?
Okay.
They are famous for shorting out just from sitting. They start leaking and they short. Okay, so I'll let you take the camera and I'm going to test these real quick. Make sure you get the meter in there. Okay, yep, they see the meter. Now back up a little bit. So the cap is right here. Okay, hey, over here. So I'm measuring this cap and take a look at the meter. Look at the meter. Pretty much shorted, okay? That's a little over 100 ohms, and I'm going to check the other one. See the other cap? Okay, same deal. Alright, so those caps are bad. Luckily, I've got a set of replacements, okay? So I'm going to get those changed and we'll retest, right?
Right.
All right, I changed out those two caps that are normally shorted out in these things, so let's check it. Ew. Take a look at the meter. What do you see there? Hold on.
Is that good or bad?
That's not good. That's 10.5 ohms. Here's the other cap I changed.
Oh,
Like
that's
0.5
terrible.
ohms. So guess what? The caps were not bad. In the past, I've had those caps short out and cause this identical problem. But obviously this detector has something else shorted on what I call the power rails, okay? So the power comes in and it's distributed across all the parts. Something else is shorted. So this is going to turn into a very time-consuming repair, right? So I think what I'm going to do at this point is just kill it. I'll contact the owner and see what he wants to do, because
You know, it's not too late to turn it into a guitar amp.
you know, I would do it, but it's not mine. So first, let me get a hold of the owner, see what he wants me to do, and impart. All right, you know, I was like ready to give up, and I thought, you know, like I said, we're going to contact the owner, and this was going to get involved, right?
Right.
So I got the bright idea. I'd come out here and just power it up, see how it's pulling all that current. Remember I told you that was not normal, okay? And remember I told you about my smoke test little theory that I have done on things like this in the past? I apply overcurrent and I wait for something to get hot. Remember the story I was telling you? Here's what I want you to do. Right in here, you see that little orange cap right there?
Mm-hmm.
I want you to put your finger on it. Go ahead, it won't hurt you. Just put your finger on it.
Oh, that's hot.
Yeah, it's hot. Yeah.
That's really
Isn't
hot.
that crazy? So that cap is what's causing the problem. There's a little stinking orange cap.
Ooh.
Yeah, I call them jelly beans, okay?
Ah.
I'm going to pull this out and show it to you. The jelly bean is what's causing the problem. So I'm absolutely sure of this because I've worked on some other solid state equipment, and these are a common failure. And I was sitting here looking at this thing and I saw it right there, and I looked at the schematic and it's right across those electrolytic caps that I just changed. I thought, right? So let me pull it out. It's still a little warm. Get this guy out of here. So I'm just going to do like I did before, kind of rock it out. You got to be super careful because like I told you, these boards are easily damaged. Okay? Got one lead out. Okay. And there's the other lead out. Okay. So on the board, I'm going to make sure it's marked. Yeah, it's got the positive side marked. So I'm going to put this here. I want you to grab the meter wherever you put it, and you're going to check that, okay? Use the meter, okay? This is that little capacitor. So a capacitor should never show a short like a switch. So like when you touch those together like you just did, you see that on the meter?
Yes.
You should not see that on this capacitor. So go ahead and go across those two leads. This was the little guy that burned your finger. Look at there. 1 ohm. Short city. Alright, let's change it out and retest.
Oh, wow.
Yeah. Alright, I'm going to power it up. Okay, I've got the new cap in. All looks good. Now if we see this only come up to like 1/4 of an amp and you see that stay at 6, we're in good shape. Look at there. Look at there.
It worked.
Listen, did you hear it? Listen. Now listen. Hear that? It's a working.
It worked.
We got it, buddy.
Woo.
So what's the lesson? Of course the phone's ringing.
Yes.
It's always ringing, right? It only rings when we're shooting video.
I know, right?
Yeah. So you know what? You know I got a little bummed out there because I had expectations, right? I knew those other caps shorted. I knew that was a common failure. So what did I focus on? That. What was the problem? Something
That.
else. So what's
something else?
yeah? So what's the lesson? All right, here's a self-test. I don't have the poles for the detector, so I just put the coil up on a plastic rod to keep it insulated. So here is a quarter. Quarter. It's working well. You can play with the tuning level. She's good to go.